All right, ladies and gentlemen, this is the second sheet that I would normally do with you in class on reaction mechanisms. So we're going to look at a couple of reaction mechanisms and make sure that you understand this concept. Unfortunately, my sheet didn't print out the greatest, so bear with me, but we'll just have to look at the steps or imagine the steps being kind of separated that way. The first question says, write the equation for the overall reaction. Your overall reaction does not include your catalysts and intermediates. Those have canceled out within the reaction. So in looking at the reaction, you look for commonalities. What sort of things are the same on opposite sides? So here we see chlorine monoxide on one side and chlorine monoxide on another side. They end up canceling in the reaction. Chlorine also ends up canceling in the reaction. Here it is a reactant. In this part, it is a product. So chlorine would also cancel in the reaction. So what we end up having left over here is an ozone, an O3, plus an oxygen atom, turning into O2, and there's two of them, 2O2. Notice how it is a balanced reaction. You have 4 oxygen atoms, 4 oxygen atoms. So it's also balanced within this reaction. Now, the catalyst in the reaction, when you're looking at a catalyst starts as a reactant and ends as a product within the reaction. So here we have chlorine starting as a reactant and ending as a product. That would be our catalyst in this reaction. Intermediate in this reaction, intermediates are going to start as a product and end as a reactant. So here we have chlorine monoxide that is starting as a product and ending as a reactant. So chlorine monoxide is our intermediate. In any multi-step reaction mechanism, you will have an intermediate. You may not always have a catalyst though. All right, so now we're going to look at the second reaction mechanism and write out the overall reaction. The overall reaction, again, is minus the intermediates and catalysts in the reaction. And you're able to identify those because they're on opposite sides of the reaction. So here we see HOOBr and HOOBr. Those are on opposite sides of the reaction. Those are going to cancel. We also have HOBr, opposite sides of the reaction. Those are going to cancel. I don't see any HBRs or hydrobromic acids over on the right or oxygens. We just see 2 waters and 2 bromine molecules. So that is our overall reaction left over. All right, so we end up with 4 hydrobromic acid molecules plus 1 oxygen molecule turning into 2 water molecules and 2 bromine molecules. Now, the next question, which step has the highest activation energy? The step with the highest activation energy is going to be our slowest step. So that would be step 1. Which step is the rate determining step? The rate determining step is also our slowest step. So that is going to be step 1. Identify 2 intermediates within the reaction. Intermediates are going to start as a product and end as a reactant. So in this reaction here, HOOBr or Huber starts as a product and ends as a reactant. So that is one of them. And HOBr starts as a product and ends as a reactant. So that is our other intermediate there. There is, however, no catalyst in the reaction. There is nothing in this reaction that starts as a reactant and ends as a product. That's okay. You don't always have a catalyst in a reaction mechanism. So you could just write none, whatever you want to there. Now, the last thing we're going to look at is a possible sketch of our reaction mechanism. And we're going to assume that it's exothermic, which means our product energy is going to be lower than that of our reactants. Now, since we have 3 steps, we're going to have 3 peaks in our sketch of the reaction mechanism. And since our first step is our slow step, it's going to have the highest activation energy. That is our rate determining step. So we start with our products. Our first step is our slow step. So that's going to have the highest peak. And then we have our other two steps. And because the reaction is exothermic, the energy of my products is lower than that of my reactants.